Hey everybody, last lesson of 5.5. I know 4 lessons, but try to chunk them, make them a little smaller and shorter for each one, not make them long videos. So this lesson is 5.5D. We're going to transform into standard form, and we've actually done this a little bit in 5.5A a little bit, but now I'm going to take it a little bit further and more advanced. Okay, so this just in, not really just in, but this is really important. Okay, what's flashing in front of you was that standard form A, B, and C have to be integers. And so far, every single standard form, we've had an integer for A and B and C. That won't always hold true. We call an integer positive, negative, whole number. If we have fractions, we have decimals. We can't leave it in standard form that way. It's not proper. Okay, so I'm going to explain to you today how to take care of that. So first, let's just transform an equation into standard form. Starting off very basic, actually one we've already done already. Let's transform this equation, y equals negative 2x plus 1 into standard form. What I have to do is I have to rearrange and remember get all my x's and y's on one side. So if I add this 2x here and I add the 2x to the left side, I will now have 2x, the y is positive, equals 1, and I'm done. That's it, quite simple. Now I want to make sure, is my a an integer? Yeah, it's 2. Is my b? Yeah, my b is 1, and my c is 1. Good. Done. Next, let's put this equation into standard form. Just another version. This is just an equation with everything on one side equaling 0. When we get to quadratic equations, we're always going to often see them equaling 0. Not there yet, I know. So all I want to do here is I want to get all my x's and y's to one side and my constant on the other. Very simply, I could just subtract 7 from both sides. And then I'm left with negative 7 equals, I do want to rearrange these two. Okay, I'm going to want my x first, so it's going to be a negative 5x plus 8y. And if you wanted to go one step further, we could do negative 5x plus 8y equals negative 7. Again, just rearranging equations. All of my a, which would be negative 5 integer, b 8 integer, c negative 7 integer. All right, negatives are okay. We can't have fractions and decimals, what we have here. So we have the equation y equals negative 3/7 x plus 5. And I want to write it in standard form. This is a great equation in slope-intercept form. I have a y-intercept of 5, slope is negative 3/7, so I go down 3 to the right 7. It's great to graph, but if I want it in standard form, I can't have that fraction. Okay, so we need to eliminate that fraction. How can we eliminate that fraction? What do you think we could do? Did you come up with something along the lines of multiplying by the denominator? If I multiply by the denominator, that fraction will no longer be a fraction. All right. So what I mean by that is I'm going to rewrite my equation, and this is what takes the longest about these videos is me just clicking away and writing. If I were to multiply by the denominator, if I were to multiply this fraction by 7, all right, multiply this by 7. What would happen would be my numerator is really 7 over 1, right? My numerator becomes negative 21 over 7. And negative 21 over 7 will work out to be an integer, all right? But I can't just multiply one part of the equation. I have to multiply every other piece by 7, okay? So what that means is I will have 7y equals negative 21/7 x plus 5 times 7 is 35. Okay. What I'm now going to do is I'm going to rewrite negative 21 over 7 as negative 3x. All right. And I'm going to actually add the 3x to the left side because, if you recall, I want to put it into standard form. So now I have 3x plus 7y equals 35. So this green equation is equivalent to, wrong button, oh boy, Stanley. This green equation is equivalent to this top equation right here. It's just 7 times bigger, and it's okay, but now I have integers. All right, so what I wanted to do is I need to multiply by my denominator, and that will eliminate the fraction. But I also have to multiply the other parts of the equation by that same value. All right, little step further. What if we have two different fractions? What do you think I would multiply by here to cancel out both fractions in one step? Did you say the common denominator? I hope so, because it was kind of one of the choices there. Hopefully that kind of sparked one of your memory there, you know. But if I were to multiply the entire equation, if I multiply by 5, this fraction would cancel out, this one wouldn't. If I multiply by 7, this fraction would cancel out, but this one wouldn't. But if I multiply by a number that both of them can go into, meaning if I multiply by 35, the entire equation, equals negative 2/5 x plus 6/7. If I multiply that by everything, watch what happens. I get 35y equals 35 times, well, technically over 1, we're going to multiply by fractions. That will give me negative 70 over 5x, which I know is not great, but that will divide out evenly. Plus, oh boy, I didn't see this one coming. 6 times 35. Let me get my calculator out for that one. 35 times 6. That gives me 210 over 7. Oh, I forgot my y in the very beginning. Sorry about that, but I remember now. And now what I want to do is I want to simplify this. 70 divided by 5. How many times does 5 go into 70? 35y equals negative 14x, because 70 divided by 5 gives me 14, keep the negative, plus 210 divided by 7 is 30. Right? I have all integers now. And now all I have to do is just rearrange. I have to add this 14x to get it to the left, because I want all my x's and y's on the same side. And I'm just going to rewrite it in blue. Up here, I have 14x plus 35y equals 30. This equation is equivalent to this equation. This is in standard form. Now I have an integer of an a, an integer of b, and an integer of c. Okay, so if we have fractions, we just have to multiply by either, if it's a single fraction, that denominator. If there's two fractions, we multiply by the common denominator of both of them. Practice for this is S17, 2 Khan Academies, and the Math